So we're on to part B of our analytic geometry prerequisite skills. Just a few quick reminders of some basic ideas from grade 9. So first off, I want to refer to some basic ideas around parallel and perpendicular lines. So let's first start with parallel. Of course, when we say parallel, we mean we're talking about two lines that will continue and never intersect. So they'll go on and on and on, and they'll never intersect or cross each other. So if we're talking about parallel lines, what attributes do they have in common? So parallel lines, we know, will obviously have the same value for slope. And that is because they have the same slant. It's the only way that these two lines can both have this no point of intersection. So, if I were to formulate equations for these two lines, I would see that the values for m would have to be the same. So in the case of these two lines, I can see very clearly that they have different y-intercepts, but the same value for slope that could be calculated. So that's the first idea. Let's look at the next one. So I want to remind you what we mean when we say perpendicular. So perpendicular means that the two lines are at a 90-degree or right angle to each other, right? So we could draw in that little square representing that they are at right angles to each other. So when we talk about their slopes, obviously their slopes are not the same, but they also have a much more specific relationship. We would say that, and I don't have enough room, so I'm going to write it down here. We would say that the slopes of perpendicular lines are negative, let's see if you can finish this, reciprocals of each other. So for example, if we knew that the slope of one of these lines, say for instance, was 3/5, and it's not, I haven't looked, this is just examples, then we know that the line, so we would say if m for one line is 3/5, we would say that the slope of the perpendicular, this is the symbol for perpendicular, so the perpendicular slope, we would take the reciprocal first of all. The reciprocal just means making the numerator the denominator and vice versa. And then we also make the value have the opposite sign, so negative. And there we go. So, if we knew that these lines were at right angles to each other, perpendicular to each other, we could ascertain that about the slope values. Let's do some practice. So as a reminder, to find the negative reciprocal of a number, you're going to invert the fraction and then change the sign to the opposite sign. So pause the video and try out these examples to see if you know how to get the negative reciprocal value for the given slope value. All right, so when I look at 2/3, if I want the negative reciprocal, I'm going to say that the perpendicular slope to that is going to be not just 3/2, but negative 3/2. So I flip it upside down and I change the sign. In the case where I have a number that is a whole number not written as a fraction, I need to remember that any value can be written as a fraction over 1. And so when I find the perpendicular slope to that, I'm going to invert that fraction to be 1/8. And since it was already negative, I'm going to change the sign to the opposite. And I'm placing the positive sign here for emphasis, but we know that numbers without signs are automatically assumed to be positive. Now let's look at this third example of negative 1/4. So I would say that the perpendicular slope would be, 4/1. And I'm going to change that negative to a positive. Now, typically whole numbers written as a fraction where the denominator is 1, we can just write simply just as that whole number. Oops. There we go. So hopefully you did okay with that, and you're ready to move on to the next stage where we start to employ this in some larger questions. So here's an example of a question you might have to try out as part of a bigger question in this unit. It says find a line that is parallel to the line here and that passes through the point A16. So that means we're not talking about this line exactly, we're talking about a line that's parallel to it. And so we know that parallel lines are going to have slope values that are the same. And so therefore I know that, this equation is written in the form y equals mx plus b. And so the slope value is -2, which means that the slope of my new line, which is parallel, is also going to be -2. And so now I also know that there's an xy coordinate here that they're giving me, and that coordinate is 1 and 6. And so if the new line has this coordinate in it, then I should be able to substitute in 1 for x and 6 for y, and that will allow me to solve for my unknown y-intercept. So let's do that. So here we go. So y equals, and I'm going to mx plus b, I'm going to put in -2x plus b. And now I'm going to go ahead and I'm going to substitute in 1 and 6 for x and y. So 6 is equal to -2 times 1 plus b. And just cleaning this up, isolating b. B is equal to 8. So finally I can get my equation by subbing in the value of b back in. So y equals -2x plus 8. And there I go. There's a nice parallel line. Let's try another question. So I'm hoping now that you've seen an example that you may be willing to go out on a limb and try this next question to see if you know how to maneuver it. And if not, that's fine, just pay attention. But otherwise, it would be great if you could pause the video and give this next question a chance. So the question reads, find the equation of a line that is perpendicular to the line y equals -1/2x minus 3 and passes through the point b, 4, and -9. So my critical information is here and here. And also one thing worth noting is that I want a line that is perpendicular. So I know that the slope of my original, line happens to be, there it is right there, -1/2. So I know that a slope that is perpendicular to that is going to be the negative reciprocal. So I'm going to flip that 1/2 upside down. That's going to give me 2/1, or simply 2. And since my original line had a negative slope, my new line will have a value that is positive. So I'm going to leave that as my perpendicular slope. The slope of my new line will be 2. And I also know that I have an xy coordinate that I can sub in as 4 and -9. So that is all I really need. So I'm going to go ahead and say, okay, well, I know y equals mx plus b. And I know my new slope. My new slope is just 2, so 2x plus b. And now I'm going to go ahead and I'm going to sub in this point into my equation. So I'm going to put -9 for y and 4 for x. Cleaning this up. That's going to give me that b is equal to -17. When I move my 8 over, it becomes negative. So there we go. So now what is my equation? It should be y equals 2x minus 17, and I'm done. Okay, so I'm going to be giving you some homework so that you can practice this a little bit just to get firm with it. Let's move on to another example. Just kidding, that was our last example. So what I'm going to have you also take a look at are a couple of documents that are going to be useful for you for the unit, and one of them will remind you of the types of triangles Maybe you can try to brainstorm them right now. Okay, different classification for triangles. And I want you to look at a document as types of quadrilaterals. So remember, quad means four. So quadrilaterals are four-sided figures, and there are a bunch of them as well. So I just want you to know what the characteristics of each quadrilateral makes them unique, and also same for triangles. And as always, if you have any questions, make sure you reach out.